Hi everybody, Augie Kennedy here, and welcome back to Super Awesome Calculus. We're on Chapter 3, which is called Differentiation Rules. Wow, shame. Anyway, last time we talked about derivatives of polynomials and the exponential function. This time, we also went over the sum rule, the difference rule, and the constant multiple rule. Now all of those rules, they're pretty intuitive. The derivative of a sum is the sum of its derivatives. The derivative of a difference is the difference of the derivatives. The derivative of some number times a function is that number times the derivative of the function. This is all fairly easy. Today we're going to talk about the product rule and quotient rule, and both of these are slightly more challenging. But before we do that, let's get to the big problem from last time. Now, the question last time was u equals the fifth root of t plus 4 times the square root of t to the fifth power, or u times the fifth root of t plus 4 times the square root of t to the fifth. It's very important that it looks like that for you to do this properly. Now the first thing that we're going to do with this function is we're going to change it up a little bit. We're going to change the way it's written. Instead of writing the fifth root of t, we're going to write t to the 1/5, because we remember that's what that is. Plus 4t to the 5 halves. 5 square root half. Now we have a much easier function to differentiate. U prime, therefore, is, we use the power rule. 1/5 t. Now what is 1/5 minus 1? Well, it's negative 4/5. So 1/5 t to the negative 4/5 plus 5 halves times 4 is 20 halves, which is 10. 10 t to the 5 halves minus 1 is 3 halves. 5 halves minus 2 halves equals 3 halves. So that's our answer. The derivative is 1/5 t to the negative 4 halves, or 4/5, plus 10 t to the 3 halves. Ta-da! Hope you got it. If you did, give yourself a pat on the back. Now, moving right along. Continuing, we're going to be talking about, like I said last time, or like I just said, we're going to be talking about the product rule and the quotient rule today. This is section 3.2 of James Stewart's calculus book. Now, you remember the sum rule. You remember the difference rule. The derivative of a sum is the sum of its derivative. The derivative of a difference is the difference of the derivatives. So you might assume that the derivative of a product is the product of its derivatives, but this can be very easily dispelled. Let's say we have f of x and g of x as two different functions. Okay? F of x equals x. G of x equals x squared. Now we learned last time that the derivatives of these functions using the power rule are 1 and 2x. Okay? So if we're trying to figure out the derivative d dx of f of x g of x, it should be 1 times 2x is 2x. But here's the thing. These two functions right here, when multiplied together, make x cubed. And we know that the derivative of x cubed is 3x squared. So obviously, the product of a derivative is not the derivative of a product is not the product of its derivatives. It just doesn't work that way. The way it does work is through a formula called the product rule. Now, most of the formulas that we've talked about so far are pretty simple. You know, the derivative of a constant is 0. The derivative of the exponential function is the exponential function. The derivative of x is 1. The derivative of a polynomial is nx to the n minus 1. These are easy. The product rule and the quotient rule are two rules that aren't as simple, but they're pretty easy, and you want to remember them because you'll be using them for the rest of the course. Here is the product rule. The derivative of a product, f and g, equals f times the derivative of g plus g times the derivative of f. Say it again. fg prime equals f times g prime plus g times f prime. Let's use an example so that you can see how this works. Let's say we have a function, f of x equals x times e to the x. Okay? Well, let's identify this as a composite of two different, or as a product of two different functions here. We have g of x, which is x, and we have h of x, which equals e to the x. Okay? So f of x equals g of x times h of x. Okay, that's fine. Now, using the product rule, let's break this down into its elements. The derivative of the first one, or, well, it doesn't really matter. The two are interchangeable. You can take the derivative of either one of these and then add them, since we're not using any subtraction, and addition's commutative. Now, here's the way that this works. It's going to be g prime h in this case. We can call this f if you want. Let's go ahead and just call it f. Let's call x f of x. Let's call e to the x g of x, just for the interest of consistency. Then the derivative of this function is going to be the derivative of the first, which is x, times the derivative of g of x. So we know the derivative of e to the x is e to the x. So it's x times e to the x plus e to the x times the derivative of the first, which is the derivative of x is 1. Well, it's interesting because now we can see that the derivative of x times e to the x is x times e to the x plus e to the x. Kind of interesting. The derivative seems to be larger. So another way to write this, we can factor out an e to the x, and we can say that the derivative equals e to the x times x plus 1. That's another way to write that. Yep. All right. Now, that's the product rule. Learn it, love it, and use it often, because we'll be using it very often. Like I said, it doesn't matter which component you choose to be f or g or which one you differentiate first. That's not true, however, in the next rule, the quotient rule. And the quotient rule, I'm going to write it down here. If you have a quotient, f and g, f over g prime is the same as, in this case, the order is very important. G times f prime minus f times g prime over g squared. In other words, it is the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. That one you'll need to memorize. You'll need to memorize the order because it's very, very important that you keep it in that order. Let's go ahead and let's do an example here. Alrighty. We've got f of x, or y, yeah, let's do that. Y equals x squared plus x minus 2 over x cubed plus 6. All right, let's get going. We know that we'll call the top is f, the bottom is g. So y prime, the derivative, should be, it should be the bottom, x cubed plus 6, times the derivative of the top. Now the top is x squared plus x minus 2. Using the power rule, we know that that derivative is the same as 2x plus 1. And we're going to subtract, right here, we have the top, which is x squared plus x minus 2, times the derivative of the bottom, which through the power rule, we know is 3x squared. And that's going to be all over the bottom squared. X cubed plus 6 squared. Now we're going to go ahead and we're going to expand 2x to the 4th plus x cubed plus 12x plus 6 minus 3x to the 4th minus 3x cubed plus 6x squared. And that's going to be over. I like to just, sometimes you'll just see me write g squared in the denominator, because I'll know what g is and the denominator is not going to change. And you can simplify that a little bit to y prime equals, oh my goodness, the phone's ringing. 1 second. Okay, I disconnected it. Negative x to the 4th minus 2x cubed plus 6x squared plus 12x plus 6 over x cubed plus 6 squared. Yep, there's your answer. It's pretty messy, but oftentimes the quotient rule is going to be fairly messy. It's not going to be as clean or as simple as the product rule. It's not hard. You're basically just differentiating, I mean, what we're doing right now, we're just differentiating polynomials just like we did in the last section, and we're just applying them to a certain formula. It's very simple. So that's the product rule and the quotient rule, and right now what I'd like to do is I'd like to just go over the rules that we've learned thus far. We know that the derivative of a constant of a number is 0. We know that the derivative of x is 1. We know that the derivative of x to the n, no matter what n is nx to the n minus 1. Okay? We also know that the derivative of, where is it? Here we go. Constant multiple rule. Cf prime equals c times f prime. Constant multiple rule. We also know that the derivative of f of x plus g of x equals the derivative of f of x plus the derivative of g of x, ditto for subtraction. And we just learned, also one other that I'm going to squeeze down here, the derivative of e to the x equals e to the x. And the two we learned today, the derivative of a product equals fg prime plus gf prime. And the derivative of a difference equals g f prime minus f g prime over g squared. And those are all of the differentiation rules that we've gone over thus far. You can see how we use them. You can see why the order f and g really matters in the quotient rule. And you're going to be able to use all of these. Now, next time we're going to talk about the derivatives of trigonometric functions. It's actually very, very easy. So next time should be fairly painless. So with that, I leave you with the big problem for the day. Today's big problem is to differentiate the following function. And I have f of x equals x over the quantity x plus a subquantity c over x. So go ahead, take a crack at it, and we'll see you next time. Or I'll see you next, or you'll see me next time for derivatives of trigonometric functions. Till then, I'm Augie Kennedy, and thanks for watching Super Awesome Calculus. Take care, y'all.